Okay, Thursday, April 30th, we're going to do empirical and molecular formulas, still along the lines using the molar mass. This is kind of what we did yesterday, the percent composition backwards. So if we're given the percentages, how do we find out what the formula is? Okay, a couple of definitions for you. I would write these down. Empirical formula, this is your smallest whole number ratio. Okay. Molecular formula is the actual ratio. So when we do the calculations, we always find the empirical formula first, and then sometimes we find the molecular as well if we are asked for it. If you're not finished writing, pause it to get those written down. Okay, so here's a problem. Compound used as a dry cleaning fluid was analyzed and found to contain 18% carbon, 2.27% hydrogen, and 79.73% chlorine. Determine the empirical formula. So we're going to start, and this is going to look similar to what we did before. We're going to list our elements, okay, and then we're going to list our percentages. 18, 2.27, 79.73. And I'll tell you, sometimes you're going to be given grams instead of percentages, and you do it exactly the same way. Okay, so we're basically, by using the percentages like this, we're saying, okay, if I had a 100-gram sample, 18 grams would be carbon, 2.27 grams would be hydrogen, and 79.73 grams would be chlorine. Because if the percents add up to 100, then if it's a 100-gram sample, the grams are going to match the percentages, and so we're golden. Okay, so to compare things of carbon to hydrogen to chlorine, we have to compare them in moles. Okay, so if these are grams and we need moles, okay, if you remember our factor label from a couple days ago, we need to do 12 grams of this in 1 mole. This will be 1 gram in 1 mole, and this will be 35 grams in 1 mole. Okay, now this number, when you do this division, you're going to need to keep a couple of decimal places. Okay, like 2 or 3 or 4, and be consistent as you go down your page. And of course, my first one is 1.5. That's all I can keep. Okay, and so remember, this is moles of everything. I don't even need to punch this one. Why am I doing that? 2.27 divided by 1 is going to be 2.27. 79.73 divided by 35. Okay, this is 2.28. Okay, so now this is what we have to do. Because the mole ratio is the numbers, the subscripts. Okay, but have you ever seen a formula that looked like this? Of course you haven't. And what did we say the definition of empirical formula was? Whole number ratio. Okay, so the easiest way to make a set of numbers whole numbers is to make the smallest one be 1. Well, how do we get that to be 1? We're not going to round. We're not going to just change it. We're going to divide by it, and that's going to give us a 1. Well, just like in math class, you have to be fair. If you divide one of them by 1, you have to divide all of them by 1. Okay, so divide by 1.5, divide by 1.5. So divided by 1.5. And we get 1.5 and 1.5. Okay, so when we do this, and after we divide and we don't get whole numbers, we have to do something to make them be whole numbers. Okay, let me actually insert a page right there. Okay, so if after dividing by the smallest, you have a decimal. Okay, you have to convert to a fraction and multiply by the denominator. What do I mean? Okay, so you have 0.2. Well, that is 1/5. So you're going to multiply by 5. That's the denominator. 0.2 times 5 gives you 1. Okay, so the other, and these are going to be very regular decimals. They're not going to be random things that you go, well, that doesn't fit the chart she gave us. It will fit the chart. Okay, 0.25, that is a quarter. So you multiply by 4. Okay, you might get 0.33. That is 1/3. You're going to multiply by 3. You might get 0.4. That is 2/5. So multiply by 5. You might get 0.5, which would be a half. Multiply by 2. You might get 0.6, 0.67, 0.75, 0.8. So this one is 3/5. This one is 4/5. So those are both times 5 and times 5. This one is 2/3 and this one is 3/4. So times 3 and times 4. Okay, so if you can remember these, then that will help you greatly. Okay, so back over here, we see that these are both 0.5. Well, again, what we do to one, we have to do to all. So that's going to give us a 2 and a 3 and a 3. So our formula is C2H3Cl3. So the numbers we end up with are our subscripts. Okay? So pause it if you need to. Pause it here if you need to. Here's 2 problems. I want you to pause it. I want you to try them. Yes, I'm serious. Get as much of it done as you can. Okay, and then I'll do it for you. So we will start with carbon. An unknown liquid contains 38.7% carbon and 51.6% oxygen by mass. The remainder of the compound is hydrogen. What is the empirical formula? Okay, well, it didn't tell us the percentage of hydrogen. How can we find that? Well, you always have 100%. So if we do 38.7 plus 51.6, it's going to be a 3, that's a 0, that's a 9. Okay, and so then we do 100% minus 90.3. We should get 9.7 for hydrogen. If I did that math right in my head. I'm going to punch in the calculator real fast just to make sure. Yes. Okay. So, first thing we do, we're going to divide by the molar mass. So we get 9.7. Gah. This one is 3.225. This one is 3.225. Okay, so we divide all of them by the smallest. We cross our fingers that we get whole numbers for everything. Boom. Okay, now for this number, I got 3.0077511938. Okay, if you get 3.1 or whatever 0.1, you can round to the whole number. Okay, if it's more than that, then you need to do the multiplication thing we saw a minute ago. Okay, so our formula would be COH3. Okay, pause it if you're not done writing. Okay, compound contains only phosphorus, oxygen, and zinc. Is used as a dental cement. Um, a sample of the cement is analyzed and gives 33.16% oxygen and 16.04% phosphorus. Determine the empirical formula. So this one didn't say the remainder is zinc. Okay, and so you've got to pay attention and know that this is 3 things and not just 2. Okay, and again, we're going to have to add those up to see how much is left for our zinc. So that's a 0, that's a 2, that's a 9, that's a 4. So this should be 50.80 maybe, I think. Minus 49.2. Yes. So this is going to be 50.80. Okay. So then we need to divide each of them by their molar mass. That's 16. I feel like this is 31. Let me double check. Phosphorus. Look at me. And zinc is 65. Okay, so then we do our math. This first one's going to be like 0.5, I think, ish. Divided by 31. Yep. So this one is 0.517. This one's going to be 2. Yep. 2.073, since I did 3 decimals there. 50.8 divided by 65. This one is 0.78. Okay, so I got to figure out which is the smallest. Divide all of them by that one. Cross my fingers for whole numbers. I don't think I'm going to get them. That's a 1. This is a 4. This one I don't think is going to be a whole number. Nope, 1.5. But that's an easy one to work with because we know that to get that to be a whole number, we multiply by 2. So we'll just do everything by 2. So we get 3, and we get 8, and we get 2. So our formula is P2O8ZN3. Okay, now I always write my formulas in the order that my symbols were given to me. Now I know that a metal is never going to be at the end of a formula. Okay, but if this is given to me in this manner on the AP test, the answer I have written would be accepted. Okay, I want to show you something though. We know that the metal comes first. Okay, and then P, if we reduce this, see how that looks like a much more comfortable compound, right? So this is zinc phosphate. Same subscripts, and PO4 is minus 3. That makes sense. Zinc is plus 2. That makes sense. Okay, that's 8 oxygens. That's 2 phosphorus. Now, this is acceptable. This is also acceptable. Okay? Pause it if you're still writing. Okay, so now the other part of this is the molecular formula. So the molecular formula we said is the actual ratio, because it's not always the smallest whole number ratio. Okay, sometimes it is, sometimes it's not. So if it has a molecular mass of 180, but it has an empirical formula of CH2O. Okay, so we need to figure out what the empirical mass is. Well, how do we do that, Miss Garrison? Well, that's the molar mass you've been calculating. So you're going to say CHO, one of those, two of those, one of those, times 12 times 1 times 16. 16 to 12. That's 30. Okay, so then we need to see how many times or what this has to be multiplied by to get 180. So if we do 180, which is the molecular mass, divided by 30, which is the empirical mass, pretty sure that gives us 6. It does. So that means we take this formula and we multiply each of our subscripts by 6. So C6H12O6. That should be a familiar formula. That is glucose. Okay? You've used it every day of this unit, I believe. So that is the molecular formula. Okay? You're given the molar mass. You have to find the empirical mass, and then you have to solve for your compound. Okay, so I've got one for you to practice. So pause me. Now I will tell you this. This one, you've got to find the empirical formula, then the empirical mass, then the molecular mass formula. Okay? So go ahead and pause it. Try it. Okay, so this is an organic alcohol. It's quantitatively found to contain the following elements in the given proportions: carbon, hydrogen, oxygen. 64.81, we'll divide that by 12. 13.6, we'll divide that by 1. 21.59, we'll divide that by 16. 64.81 divided by 12. That is 5.4. This is 13.6. This is 1.35. Okay, so then if you remember, we divide all of them by the smallest. We cross our fingers for whole numbers. 1, that looks like 10, unless I've lost my mind. It is 10. 5.4 divided by, I bet this is 5. Oh, it's 4. That's what I meant. Okay, so this formula would be C4H10O. Okay, molecular weight is 74, so we need to find the empirical mass. Okay, so carbon, 4 times 12 is 48. Hydrogen, 1 times 10 is 10. Oxygen, 1 times 16. I wrote this backwards. This should be 10 times 1. Let me fix it. Because you do how many you have times the mass of 1. You want to be consistent with that. Okay, and we add that up. We get a 4, 4, 5, 6, 74. Okay, so the empirical mass matches the molecular mass. Empirical mass equals molecular mass. Therefore, empirical formula is equal to the molecular formula. So this is the answer for both. Okay? So, try the problems, read the directions carefully, and I will talk to you soon. You'll have a little quiz tomorrow on all of these problems from this week. So, hope you do well. Remember, we have WebEx every single Friday. Every single Friday. I've been meaning to say that on every video, and I haven't. But I'm going to try to invite y'all with a link. So hopefully everybody will get on this week. Talk to you soon.